kind of variable types can we use in Solidity? Variables are used to store different types of information, and they are nothing but reserved memory locations to store values. When we create a variable, we are reserving some space in memory. In smart contracts, we need to store values of type character, wide character, integer, floating point, double floating point, boolean, etc. The operating system allocates memory based on the counter type of a variable and decides what can be stored in the reserved memory. Solidity offers the programmer a rich assortment of built-in as well as user-defined data types, as you can see in this table, but perhaps the best way to remember and understand them is to make some small groups. You can have fixed size types, bool, uint, address, bytes 32. You can have variable sized types like strings and bytes 1, or without predefined length like uint arrays, array, mapping, or user-defined like struct or enum. Address is a special kind of variable used in Solidity that holds a 20-byte value representing the size of an Ethereum address. Now here in Remix, let's use some of the most common value types. Let's start with bool. So this is how we declare and assign a bool. A bool can hold two values, true or false. Solidity supports all the regular Boolean operators, and they take up 1 byte of storage. Signed and unsigned integers. Signed integers are declared with the int keyword. So this signed integer equals -1 to 3, and this int is equal to writing int 256, which ranges from -2 to the 255 to 2 to the power of 255 minus 1. Unsigned integers are declared with the uint keyword. We have a uint public unsigned integer equals 12, and this uint is equal to writing uint 256 and ranges from 0 to 2 to the power of 256 minus 1. If we know the size required for the variable, we can explicitly specify the number of bits in steps of 8 from 8 to 256. For example, we can have a uint 8 that ranges from 0 to 2 to the power of 8 minus 1. Also, if you want to know the minimum value of an int, you can assign this type int.min to an int variable to know the min value and do a similar operation to know the max. Address, as you might guess, it is extremely important. You should know that there are two types of addresses. We have externally owned addresses. An externally owned address is an address to an Ethereum account, just like an inbox has an email address. You can use this to send and receive funds. We also have the contract address, that is an address associated with a smart contract, and it is used to send and receive funds to and from that contract. In both cases, the address is in the format of a 42-character hexadecimal address. The address is derived from the first 20 bytes of the public key controlling the account or deploying the contract. So every address takes up 20 bytes of storage. You declare an address like this. Fixed size byte arrays contain a sequence of bytes. The length of the array must always be specified in the type declaration. They are declared in the following way. Byte is an alias for bytes 1. You can use your regular Boolean operators, comparison operators, and bitwise operators on this type. Note that there is another type, called bytes, which is different from the above in that it is a dynamically sized array and not a value type but a reference type. It is basically a shorthand for byte array. It is always good practice to use some bytes 1 to bytes 32 because it is much cheaper. A byte may allocate byte values in hexadecimal format. String literals and hexadecimal string literals can be implicitly converted to fixed size byte arrays if their number of characters matches the size of the bytes type. Fixed point numbers are not truly fully supported by Solidity yet. They can be declared but cannot be assigned to or from, so we will leave them aside for now. Enums in Solidity are a way to create user-defined types. Enums are explicitly convertible to integer types, but not implicitly. Enum values are numbered in the order they are defined, starting from 0. Let's see an example. We have an enum actions that has these 4 actions created. We declare this action variable of type actions. We set this default action to go straight. Enums are not part of the API. This means that if a function returns an enum, it will be automatically converted to a uint behind the scenes. Let's see that. You can see that the setChoice function is expecting a uint value as part of this conversion that Solidity does. Last but not least, structs are custom-defined types that group several variables. So this user struct has a string name and the bool is cheap. These 2 variables are grouped inside the user struct. So this is it. For more information and also for knowing the conversion rules between types, check the Solidity documentation. Make sure you like and subscribe so you can be notified when I upload the next video. Thanks for watching.